Thanks for joining me here today at Spartan Controls virtual booth. My name is Brian VanVliet. I currently collaborate with folks just like you to provide solutions to industry in Western Canada that improve environmental outcomes in the areas of air quality, water innovation, GHG reduction, and production optimization. By reducing emitted fuel gas, we have helped meet increasingly stringent environmental regulations while improving process performance, reliability, and safety. Spartan is the leading provider of automation, valves, measurement, process control solutions, and services here in Western Canada. For over 55 years, Spartan has provided customers with high-performance solutions, industry expertise, lifecycle support, and technical training, delivering value our customers want. 14 locations across Canada to serve and support our customers. Our technology has removed over 9 megatons of CO2 to date, which is the equivalent of almost 700,000 cars off the road. Environmental regulations pertaining to methane that industry is faced with today have reached a tipping point and have become significantly more stringent, especially for the upstream oil and gas industry. Achieving a 45% reduction in vented methane from upstream oil and gas assets by 2025 is a goal that is not only achievable, but you can get paid to do it. How is that possible, you ask? Well, let's unpack it. Okay, so starting with electric valve actuation. Here we're ensuring we have the energy for fail-safe positioning. We can do that with electro-hydraulic actuator technology, in which case we have stored energy for fail-safe positioning. Hydraulic fluid pressure energizes gas-charged accumulators or compresses the actuator spring. This is a self-contained system with a built-in reservoir, and it works effectively today. We can also look at electric fail-safe actuator technology with the use of batteries or supercapacitors, and we're storing that energy in an accumulator. Pure electromechanical fail-safe functionality like a spring guarantees valve safety positions are achieved in the event of power failures. Next, we have electrochemical injection pumps. They're used to inject methanol, corrosion inhibitor, dewaxer, and other chemicals to promote reliable production. The Lco Crossfire Pumps perform the duty of up to 4 conventional pneumatic chemical injection pumps. They provide continuous to proportional flow delivery. It's demand-based that optimizes chemical usage as well and reduces operating costs further. Here we see self-contained regulators. They regulate the pressure control, and it can be achieved using devices that sense either downstream or upstream pressure to open or close proportionately to ensure the pressure remains near the set point. This is a non-venting technology that has been used primarily in downstream natural gas distribution, but it can also be applied to upstream hydrocarbon production. Next, we shift over to instrument air. So here we're maintaining the reliability and we're eliminating emissions. So conventional control loops in the upstream oil and gas industry have been used with fuel gas pneumatics. This form of motive power can be replaced, though, by instrument air, which maintains the reliability of assets that have been fit for purpose for decades. Instrument air eliminates the methane and volatile organic compounds that would otherwise have been vented. Power supplied from the hydro has much lower carbon footprint than other forms of non-renewable power generation. We can also look at other ways of eliminating vented emissions. So if we look at high-integrity pressure protection systems, known as HIPs, we prevent overpressure by reducing flare loading, environmental impact, pressure, and the size and cost of the flare system. In new plants, it can reduce the size and cost of relief valves, relief piping, and flaring equipment, therefore saving capital expenses. HIPs is designed to close the valves, isolate the process at its source when there's an overpressure event is detected. Recently, we've had focus on tanks as well. Thief hatches are an asset that's used on tanks, and they provide access to help mitigate point source emissions under normal operation. They improve the seal and reduce the overpressure during relief events, while reducing vented emissions. Thief hatches are designed to be used in applications where tight sealing is critical to prevent the loss of vapors in a closed storage system. So if we look at pressure vacuum relief valves, they also are used on tanks, and they provide vital pressure control as the tank pressure increases or decreases due to pumping in liquid, or out for tanks, or temperature changes, or outgassing. They ensure the tank remains closed under normal operation, eliminating the loss of vapor from the tank headspace. If we can't mitigate the point source, we could look at a vent gas capture as well. So slipstream is a technology that captures gas vented from point sources such as instrumentation, cactus dryers, glycol dehydrators, condensate tanks, compressor packing vents, and wellhead casing. It can be captured and combusted. This eliminates the use of fuel that would otherwise be required to operate the engine, flare, generator, thermoelectric generator, solid oxide fuel cell, or heater at site. This can be used as a supplementary fuel source that improves efficiency while reducing CO2 and VOCs. Another form of electrification includes variable frequency drives. They increase energy efficiency and can be applied to many variable speed systems to increase the overall energy efficiency and reduce power consumption. Applied to a compressor, a VFD provides compression controlled by a motor rather than valves and diaphragms. The energy needed to start and stop a system is also minimized using VFDs. A pump jack and consequently production at the wellhead can be optimized with variable speed control for the measured downhole conditions. As I've touched on, there are many ways to tackle this. To be cost effective on a purely economic basis, the savings need to be worth more than the cost of the solution. That's where the connection to royalty reductions, the generation of emission performance credits, carbon offset credits, PTAC, MCP funding, the baseline reduction and opportunity assessment program, and the methane technology implementation program, among other programs, is enabling. The world is trying to change, and with levers like this, there are pathways that can make sense and are being put into action. I encourage you to contact us today and find out how Spartan can help you with measuring GHG emissions, mitigating consequences, achieving compliance, and optimizing performance. Reach out to us at Spartan Controls. We are doing this today with people just like you.